Okay, bismillahirrahmanirrahim. Assalamualaikum. My name is Abdul Hadi bin Muhammad. Nombor metrik 24110897. Today I will discuss about Reynolds Transport Theorem, iaitu RTT. Okay, introduction of RTT, Fluid Dynamic and Control Volume Analysis. The Reynolds Transform Theorem RTT offer a mathematical framework for converting between the rate at which property in a system change and the rate at which property change in a control volume. The next iaitu system approach dengan control volume approach. System approach refer to analyze a fluid flow problem from the perspective of a fixed mass or a control mass, as opposed to analyze it based on a control volume, as in the volume approach which we discussed previously using the Reynolds Transform Theorem. And the next control volume approach, a basic technique from examining fluid flow and the movement of characteristics such as mass, momentum and energy. Cross a control volume CV is the control volume approach in fluid mechanics based on a Eulerian viewpoint. This method examines the fluid characteristic as it passes through a control volume specific fixed place in space. And the next different system approach dengan control volume approach. System approach ni aspek dia iaitu fokus fixed mass of fluid tracking individual particle, region of space control volume that can change shape or position. Second, perspective, follow the motion of individual particle, focus on how fluid properties change at fixed point in space. The third approach, Lagrangian, yakni tracking mass, Eulerian pula observing fluid passing through a fixed volume. The second last mathematical formulation, direct conservation of mass, momentum and energy for a fixed set particle as a Reynolds Transform Theorem formula. Example, tracking a path of a specific particle in the flow, analyze the flow through a pipe or the dynamic with a boundary. Okay, the next page is formula. At time t, the control volume CV and the system are the same. They overlap completely as shown in the green sheet region. However, as time progresses to t plus delta t, the situation change. Now the control volume remain fixed in space, represented by the dash red boundary, but the system which consistent of the same material shift and over wide the flow. At this new time, the system move into the hatched purple region labeled 2, while it exists the green shade region labeled 1. The change highlight the key concept material flow in through boundary 1 at velocity 1 and out to boundary 2 at velocity 2. During this time step, the system can be expressed mathematically. System at t plus delta t equal to control volume minus region 1 and region 2. Is essence the control volume approach focus on the fixed region, analyze inflow and outflow, while the system track the same material as it move. This destination is essential for understanding how fluid mechanics and conservation law are applied. Okay. First, we know that B represent extensive properties such as a mass, energy, or momentum, which depend on the size of the system. B equal to B over M represents in intensive property which are independent of the system size, like temperature or density. Okay, the system and control volume perfectly overlap. This means that the property of the system and the control volume are the same. Okay, at time t plus delta t, the system involve and move while the control volume remain fixed. The property of the system at this new time can be expressed as bt plus delta t equal to bcv t plus delta t minus b1 t plus delta t plus b2 t plus delta t. Okay, the next we take the difference in the system property between the two time t and t plus delta t. This given bt plus delta t minus bt equal bcv t plus delta t minus bcv t minus b1 plus delta t plus b2 plus delta t. This equation reveal how the system change in property over time depend on change what the control volume and the inflow and outflow at the boundary. Okay, we start by subtracting the system property equation and dividing by delta t, taking the limit as delta t equal to 0. We get dv over by dt equal to db cv over by dt minus b in and plus b out. Okay, this equation show that the system rate of change depend on the control volume change and the inflow and outflow rate. Inflow and outflow rate are expressed as b in equal to b1 p is density, v is velocity, and a1 is area. B out same b2 density 2 velocity 2 and area 2. Okay, where b is the intensive property, p is density, v is velocity, and a is area. Substituting this into the equation given, db over dt equal to db cv over dt minus b1 density 1 velocity 1 and area 1 plus b2 density 2 velocity 2 and area 2. Okay, the next page, RTT with a fixed control volume cv. We assume that the control volume is not moving relative to the fluid flow. This is also known as the Eulerian perspective in fluid mechanics. The key difference in the context is the we are considering a control volume that remains stationary while the fluid flow through it, and we analyze the quantities within this fixed volume as the volume pass in and out. Okay, RTT fixed CV control volume CV. In the case of a fixed control volume, the region of the interest remain stationary in space, and we analyze the behavior of the fluid as it passes through this fixed alternate RTT. Express the rate of change of a property such as mass, momentum, or energy in a fluid element moving with the velocity field V. Okay. The next part, the general form of the RTT for a non-fixed control volume. In the context of steady flow, the RTT simplify considerably. Steady flow implies that the properties of the fluid do not change with time at any given point with the flow field. That means that the time derivative term in the RTT becomes zero. Simplify the equation and making an analysis more straightable. Okay, the next page. For a control volume with well-defined inlet and outlet, we focus on the transport of a property such as a mass, momentum, or energy across the control surface, which consists of the inlet and outlet boundary. In the case, the control surface is typically fixed, and we can treat the flow as steady or unsteady depending on the problem. Okay, that's all for me. Thank you for watching my video.